What's up, scholars? Today we're going to be applying our trigonometry to the unit circle. But first, I want to give you a little bit of some history of where trigonometry comes from, because it's kind of cool. Trigonometry, like, what does this word even mean, right? There's the first part, trigon or trigono. Anyway, first part means triangle. And the second part, metry, means measure. So when we're looking at trigonometry, we're looking at triangle measure, right? And I'm going to put this on a circle, and you're going to be like, wait, what does a circle have to do with triangles? I have no idea. But this is going to be really mind-blowing. Trigonometry basically is the relationship between side length and angle measure. So now let's talk a little bit of the history of trigonometry. I gotta say, a lot of people give the Greeks all the credit for trig, all right? And they call it like the golden age of trigonometry, right? And so really, this wasn't until about 190 to 120 BCE. Before them, we had the Egyptians and Babylonians. Wasn't quite enough space right here, but this says Babylonians, right? The Egyptians and the Babylonians, and they were way, way before what everybody did in Greece. And what was really cool was to build the pyramids, right? What Egyptians did was they looked at a rectangle and they basically cut it in half. And they said, well, this is the diagonal, and they did D for diagonal. And then they represented the long side and the short side. And they looked at how the ratios of all the sides like fit together for the triangle, which is really cool. We know this is like Pythagorean theorem, and we look at that a lot, right? The Babylonians really went on this sexagesimal system. I don't really know how to say it. And this was really just base 60 counting. Notice the sexa prefix, right, meaning 6. And the Babylonians got this from the Sumerians, the people that were living in the same region, but they were like just before them. So they like really like taught them all this stuff, right? And we still use base 60 in all, like a bunch of things that we do today, right? So if you look at time, you look at the clock, there's 60 minutes in an hour, 60 seconds in 1 minute, right? We're still using this. We also still use it for lots of angles, geographical coordinates, all kinds of things. We use base 60. There was like this really cool tablet that was found, and it was found in Iraq, and it's got like 15 lines of numbers on it, right? Oh, and actually, I want to show you this tablet. All right, so here it is. And just to give you an idea of the size of it, you could hold up both of your hands and then the tablet would fit like on top of both your hands, right? So it's not very big, which I think is kind of cool, but it's got 15 lines of stuff. And this tablet was found like at the beginning of the 20th century. I don't know, like I want to say like 1905 or 1900 or 1910, somewhere in there. This thing was found and it was discovered, and they didn't know what it said, right? And so we thought that all of our trigonometry came from Greece as well. I mean, we knew that like the Egyptians like knew a bunch of stuff. I mean, look at the pyramids, right? We knew this, but we didn't realize how much legwork was really done by the people who were living in the Middle East at this time. And they didn't even figure out what all this stuff meant until like the 1970s. Like legit, the 1970s. That's pretty crazy. This tablet was a bunch of it was a table, it was a trigonometry table. They were looking up how the long side of the triangle matched up with the diagonal and the short side. So this was really cool. We finally had evidence of people calculating what we know today as trigonometry. So what this awesome tablet was showing, right, is what happens when we take a triangle. And what happens if we spin this diagonal, the hypotenuse, up a little bit, right? We keep that length the same, but we spin it upward, all right? This comes down, and now the height of the triangle, the long side, got taller, and then the short side actually got a little shorter, right? And they just keep spinning this thing. And this is what their trig table is representing, this relationship between moving this around. So now what you're going to learn how to do today is we're going to put this on a circle. And this is what happens when we take triangles and we put it on a circle and then we just spin that triangle around, right? It makes different varying triangles. And we're going to look at how it changes in the X direction and how they change in the Y direction, right? And so that's just how is the long side getting longer as we go up and how is the short side getting shorter as this moves around the triangle. So this is really cool. This comes from 3000 BCE, but this is like some super, super cool, rad stuff. So there's a little history.